Okay, so did you guys all draw this picture here? This time is this 270, and then you rotate this much. So this right here represents the minus theta. Okay, so 270 minus theta. Again, the angle is off of the y-axis, not the x-axis. So if I were to rotate only theta and compare with only the theta rotation right here like this, that looks like it's about theta. First, what is this? That length is equivalent to this length. Okay, so let's call that minus a. Cosine by definition is the x value, okay, of that point. Okay, so if I label that minus a, just to describe this better, I'm going to label that b. What will be the coordinate of that point? Okay, so you got to use relative perspective here. See this minus a? Do you see that the blue line I just drew there? That's the same length as this minus a. So do you see that opposite to the angle theta? Opposite has to be a minus a. So look, do you see that the opposite of this has to be a then? And then look, do you see this angle theta here? What's adjacent to it? That's the same as minus b, right? But because we're talking about in the first quadrant, this must be b. So this is b and this is a. So the coordinate is ba. So what is a? Okay, what is this in the first quadrant? What ratio is that? What's the y value? It's sine, right? So it's equal to minus sine theta. Okay. Now, if your relative theta is off of the y-axis, you can see a pattern. Cosine changes into sine, and sine actually changes into cosine. It changes. Okay. The 180 minus relative angles, or 180 plus relative angles, it stays the same, but this one changes.